All right, so substitution method. Really what we're trying to do in this entire unit is basically solve for x and y. So I gave you two equations and I want you to be able to solve for x and for y. So it requires a little bit of effort. The first method that we use is substitution, and that is a method of solving systems of equations by substituting equations within one another. I will also tell you that anytime I do these lessons, I am recording them. So if by some chance you would rather watch and then take your notes down later, then that would work too. Or you can kind of go in between both of them. But if you miss something, you can always go back and look at the notes. Okay, so step one, solve one equation for x or y. And I can change the variable so it doesn't, like, basically I'm going to take one of the equations and solve for one of the variables. Okay, then step two is I'm going to substitute. To the other equation and solve for the variable. Then you substitute your answer. There's a lot of substitute. And then we solve. Probably easier when we actually look at an example like example 1. Both equations are solved for y. So I can take my 4x minus 1 and I can substitute it in for y in my second equation. And then I'm going to solve for x. So I get 2x minus 1 is equal to negative 5. Add 1 to both sides. 2x is equal to negative 4. Divide by 2, and I get x is equal to negative 2. That gets me all the way to step 2. My last step is to take my x equals 2, negative 2, and I can substitute it in. And it doesn't make any difference. Pick whatever equation you want. You either pick the top equation, because it comes first, or you can pick the bottom equation. If I pick the top equation, I plug in negative 2 in for x, and I solve. So y is negative 8 minus 1, so y is negative 9. So my solution is always a coordinate point, negative 2, comma, negative 9. Questions that you guys have? Okay, so which one do you like? Do you like question 3 or 4? 3? Okay. First of all, any questions about example 1 before we do 3? Okay. So I have already y equals x plus 9. And I'm going to put that into my second equation. Why is it not writing? It froze. Oh, there it is. Okay. So I have my 3x plus 8, and I'm plugging in x plus 9 in. And that's equal to negative 5. To solve for x, I'm going to go ahead and I'm going to distribute my 8. I'm going to combine my like terms. So I subtract 72 from both sides. And I get 11x is equal to negative 77. Divide both sides by 11, and I get x is equal to negative 7. So once I get x equals negative 7, I can plug it into either one of the equations. It is easier for me to plug it into the top equation than it is for me to plug it into the bottom equation. So I get y is equal to a positive 2. So I get negative 7 comma 2. Questions that you guys have? Yes.
It's in the second equation. It's 3x plus 8y. Why doesn't the 8 have the y when you plugged it in?
Oh, I took this y here. Sorry, I took that y and I substituted the x plus 9 in for the y.
Oh.
So then the y went away. Yes, Mason?
Alright, so would the answer be the coordinate point?
Yes, the answer is the coordinate point.
Alright, is that what we were supposed to do in our last homework?
So in the last homework, you're supposed to get that coordinate point by graphing. It is very difficult unless you're using Desmos or a graphing calculator to get that exact coordinate point. But in theory, yes, you were supposed to be able to do that without doing elimination in the last homework. Yes.
I'm a little bit confused on how we get the coordinate point.
Oh, x comma y. Huh?
How do we know what y is?
Because I solved for it. I plugged in negative 7 in to my equation here to get what y was. Questions? Other questions? I know that one was weird because it didn't look like we were actually plugging in. I laugh. You're like, no, don't do it.
Nope.
I was gonna try to give you a choice. I was like, do you want to do 6 or 7?
7.
But I have to do. But I actually have to do 7. I was like, I actually have to do 7.
I have to restrain it now.
I have to do 7 for a reason. I was gonna try to give you a choice, and I was like, oh man, I look at the answers.
Oh.
Huh? Yeah, well, because it's weird. I'll show you. So if I look at 6, no, I lied. If I look at 7, none of the equations have a variable that's by itself, right? Everything is in standard form. So which equation is easier to put into like a form where you have just one variable on one side. Yes, Trejo.
The first one, you minus 5y.
The first one is better. So if I choose the first one, I can just subtract 5y from both sides and get x by itself. What I'm going to do is I'm going to take this equation that I just solved for, and I'm going to plug it in for my x in my second equation. So I get 3 times 4 minus 5y plus 15y is equal to negative 1. And that's the key. I'm not taking that top equation and re-plugging it into itself. I have to take that top equation and plug it into something different. Okay. All right, so I distribute my 3. Oops. And so what do you get? Well, you notice that all your y's cancel out. So I'm left with 12, which is not equal to negative 1. What? So there's no solution. So when all your variables cancel out and you don't get something that's equal to each other on the left and the right, then there's no solution.
Wouldn't that mean they're parallel?
Yes, that means that they are parallel lines.
How do you know if there's infinite solutions?
Good question. Let's look at 9. 9. So which equation is better to solve for one of the variables? The first equation or the second equation? Second equation. Because the y has a coefficient of 1. So if I move 2x to the other side, I get y is equal to negative 2x plus 18. Now I can take that negative 2x plus 18 and I can plug it in for the y in the first equation. So I have 6x plus 3 times negative 2x plus 18 is equal to 54. So I get 6x minus 6x minus 50, plus 54 is equal to, oh my gosh, 54. And what do you notice? The x's go away, and I'm left with 54 is equal to 54. So this is infinitely many solution. Because I got a true statement.
I just multiplied it while
We're not doing elimination right now. You cannot use that method. Yes, Mason.
If the number equals a different number, it's no solution. If the number is equal to the same number, it's infinitely many solutions. And if a variable is equal to a number, that's one solution.
Correct. Good job. All right, questions that you guys have?